am a teacher in Sioux City. And I'm excited to see what you guys have all done with this tonight. I'll let you.
I'm Kat. I work IT, but I did FTC for a little while, and I really like robotics. It's part of my degree. So I'm really excited to go do this as a robot.
I will be Justin. I used to be in this position, Blueberry. I work at an auto shop currently.
Go ahead.
Good morning, judges. We're Tech Seconds 2, and these are my team members. My name is Vidya, this is Arush, this is Sariu, this is Lovis, and this is David. This is a robot picture, and these are the key elements. We built the robot looking at the challenges and movements. So today I will be talking about the wheel designs. So first we put 2 wheels, but then it started shaking and wobbling. So then we added these 4 wheels on the back to keep it more unstable. We added 2 ball casters in front to move left and right. We used 2 motors for these 4 wheels in the back. We used 1 motor for the left 2 wheels, the other motor for the right 2 wheels. Now I'll pass it over to my friend Arush.
Hello judges, my name is Arush, and today I'm going to be talking about the design for our arm for the robots. So the question is, how do we actually came up with this arm design? Well, after reviewing the missions and understanding our goal, we came up with an arm with some gear meshes to help the arm work precisely good. So there's 2 gear meshes. There's the step up and the step down, and that's all part of the gear ratio. I'll face it to you this way. Pretend you have a big gear and a small gear. If the big gear wants to spin the small gear 3 times, it has to make 1 complete turn. But if the small gear wants to spin the big gear 1 time, it has to make 3 turns. That's gear ratio. Also, if you see here, there are these finger-like pieces right here. They're actually used to help pick up stuff, like it can fit through the loopholes and then pick them up. Now that concludes my topic. Now I pass on to my friend Sariu.
Hello judges, my name is Sariu, and today I'll be talking about gear systems. Why do we need gear systems? For 1 motor and 3 arms. Why do we need 1 motor for 3 arms? We have limited ports on our hub. When we were doing our missions, we faced a big challenge, which was gear slippage. To avoid that, we locked the gears in place so the gear mesh can happen. Now I'll pass it on to my friend Levin.
Hello judges, my name is Levin, and I'm going to be talking about the distance sensor and our wall check algorithm. So how the distance sensor sees is that it uses echolocation, or you could call it sonar. So the transmitter is going to send radio waves, and then the object will bounce back those sound waves, and then the receiver will calculate how long it took for those sound waves to come back. So its main principle is echolocation. So, and then how the distance sensor works in our code, it uses so it checks if the robot is too close to the wall. If it is too close to the wall, then the robot will signal to the hub that the distance sensor will signal to the hub that the robot needs to go farther away from the wall. So now I'm going to be talking about our wall check algorithm. So first we start it, then the distance sensor measures nearest wall. So that will be known as Y. Then the user defined distance, that's X. If X is less than Y, if it is, then the robot moves forward. If it does not, the robot does next operation, or the robot comes to a complete stop. Then the algorithm is stopped. Now over to my friend David.
Hello judges, my name is David, and I'll be talking about our left and right turn algorithm. So as you can see right here, our hub has 3 ways to measure movement: yaw, pitch, and roll. Right now we're going to be using yaw to make the perfect turn. Now let me tell you about our algorithm. So first, when we started, we set our motors to the 2 motors in the back. Then we use that. So then the program sends the exact turn it has to go to in degrees to the algorithm. The algorithm will then
use the absolute of yaw to turn to that angle that I got from the program with its T motors. Thank you, judges.
Thank you.
So did you have any, like, trial, like, I know you talked about at the beginning, you started with 2 wheels and then you went to the 4. So did you have, like, do some testing and try different things, or?
Yeah, we did testings, but then it started shaking a lot, so then we added 4 wheels to keep it more stable.
In the regards of the arm you used to manipulate items, oh,
No, you're okay, they're okay. We're good.
your arm there, your fork, is that your first design of it, or did you go through any iterations?
Well, I do remember making hang on. Well, yeah, this is my first design. We all worked together on it. And this arm is usually for the first mission. Like, it was just actually for picking up stuff. It was like the fork can help go through the loopholes and then pick things up.
Actually, what my friend meant to say was, that was actually not our original design. Our original design, as you see, it has 6 of those like finger-like pieces. But our original design had 4 finger-like pieces. So, and then we added those because it was like, with 4, it was like less, so like, it was like not a wide base and it was like really hard to get the test done.
That was very nice. Nice way to put that.
How did you guys settle on the sonar methods? Well, like, why did you guys choose the sonar?
It's because like the color sensors on the back, as you see in that picture, they weren't really like working that good. So we decided to use a distance sensor where it's more precise.
How did you guys divide up work for this?
Well, we divided each group. Well, we decided to do 3 on the red side and 2 on the blue. Me, Levin, David on red, and Ditya and Sari on the other.
So like, on the red side, there's gonna be 3 people, but there's supposed to be 2. So one person's gonna stand in the back and 2 people are gonna do the mission. So then the person who does the mission goes back, and then the person who is back goes front.
What was probably the easiest thing to work together on?
It's like the mission.
We all work together to build an arm and test it out.
Yeah, that's okay. There you go.
Pretty easy.
When something went wrong while you guys were working on your missions, how did you decide to change the robot versus changing your code?
So we decided to change the position at first, but if the problem kept happening, then we would like start looking at the robot and make sure everything was tightened. If that doesn't work, then we change the code.
Because like the code works, and so sometimes it can be the robot's problem and the people's problem.
Do you guys want to bring your robot closer so that we can take a look at it? You can set it right on this folder here.
So this is our arm. These are my motors.
These are the gears.
These are the 2 motors, and these are the gears.
There's gear ratio.
Okay. There's also one for our fixed arms, so these fixed arms would never come off.
And on the bottom, this is our clutch sensor, but it doesn't really burn that much. So this is our distance sensor.
This is our steering. We usually clean them.
We usually clean them to move left and right.
Oh yeah, and this is
To
the
make things more
ratio.
smooth.
And then use this, and use this, then use this to control the arm, and this, can use this, can use this, can use this, and have to use this arm.
You see that little gear in there? And
How often do you have to clean the front wheels there?
If it starts like, if it doesn't jerk, if it starts jerking, we usually clean the wheels so if it moves straight.
So, oh, do you have attachments that you put on, or you've got everything on?
Yeah, we have attachments we put on.
We
Okay,
have like different arms for different missions.
okay, okay, oh. Very good.
So once we do the missions, this is like where the arm usually goes. It can also go on the bottom, down, like somewhere down here.
Oh yeah, and even on this fork-like arm.
Yeah.
Quick attachment to this.
How limiting would you say the size of your robot has been when it comes to completing missions?
I'd say that it does sometimes cause some trouble. So it sometimes limits our access to some of our missions.
you guys can take that back. Awesome.
If you'd had more time, is there anything else you would have done to your robot?
Nothing much. Well, we would have tried to make it a bit. We would have tried to make it a bit smaller.
Okay,
So they can fit around the tight spots.
yes.
And sometimes a robot, falls off the edge before the board, the robot falls off the edge
Yes.
and like it breaks. So
That's why we added the
walls
walls.
really,
Yeah.
yeah, the walls really helped. The distance sensor helped a little bit too.
Our robots define the way it really is. I think it's efficient.
Efficient.
Very good. Well, thank you, and I hope you have a great rest of your season. Any other questions?
Oh, my questions, I think that's it.
No, it sounds like you worked really well together, so, I do see, I haven't seen the actual for this year, but, I do get where I've seen past boards that might be a bit cumbersome, but no, I think it sounds like you all contributed and worked very hard together.
What was your favorite part?
Definitely testing the robots.
Mine is the poster part.
Yeah.
Yeah, I really like
Mine's
the
making the logo.
Yeah.
Is one of you the artist for the dragon?
We all contributed.
Oh, okay.
Yeah, we all contributed.
Yeah, no, that is cool. Sorry, it's been a little while since I've done this. Well, this completes your judging, this completes your judging session, sorry. Anyway, thank you for sharing your hard work with us, and